Pues ya sin más dilación, creo que vamos a dar paso a Nassim Haramein.
Buenos días. It's great to be in Spain. Gracias. Gracias. It's great to be in Spain. I wish I knew a little more Spanish. Thank you so much for coming. Thank you for being here. I'm really excited to present this work to you. There'll be a lot of things that were there that you might have seen before, but we'll get in more details about it, and then there'll be new stuff. I'm going to present some new stuff. Can you all hear me in the translation? Good. I really love this country. I went and traveled a little bit through it. It's wonderful. I went to Basque and surfed a little bit. So you guys have great surfing. I'd love to go climbing one day here. I'm excited to bring some of this work to you because, you know, we're at this moment in our evolution where we have to make some changes. We have to make some changes in our society. We have to make some changes in our world so that our society can thrive, so that the generations to come have an earth to live on. And in order to be able to make these changes, we have to do some radical changes as well in our philosophy, in our understanding of the universe, in our understanding of our relationship to the universe. The current thoughts are very much based on the concept that things are separated, that things are individualized, that a point over here and a point over there don't necessarily relate to each other. So I can do this over here and not worry about this over there because it's not going to affect it. And as we grow, as we expand our society, as we grow on this earth, we're starting to realize, no, we're starting to realize, oh, everything seems to be interconnected. If I change this too much, then this will start to go out of balance, and then this wobble will produce this other wobble and all this. And so now we have to understand how things relate to each other, how they connect with each other, so that we can regain balance. Yes? And so part of what I'm going to present today to you is the result of a small paper that's making a lot of noise. I have to dodge a lot of tomatoes and rotten eggs, you know. It's a small paper that I published last year in, well, actually it's in the process of being published. It is going to be published in the next few months in one of the largest scientific physics journal. And it was presented at a conference in Liège, University of Liège, in the Department of Mathematics, and it's called the Schwarzschild proton. And I was really excited to be able to present that paper because, you know, usually when I want to present papers to the scientific community, I apply to put it in, you know, the conferences, and then, you know, I hope that I will be able to present it. But in this case, for the first time, you know, the conference asked me to present a paper. That is, it was an invited paper. And so, because it was an invited paper, I thought, oh, I can say what I want. So I went for it. And I made this very simple paper that any student that has done a little bit of mechanics, a little bit of math can follow. And so today, we're going to actually do a little bit of those math. Don't panic. It's not going to hurt. It might hurt a little bit, but then it's okay. And I'm going to run you through the equation that describe this new view of the quantum world, this new view of the material world we live in. And, you know, when I presented it at this conference, although it was an invited paper, I thought, oh, you know, it's very radical. Maybe I get in trouble anyway. And so when I arrived at the conference, I was a little nervous. And, you know, in the middle of the conference, the director of the conference came to me and said, I would like to talk to you. And I thought, oh, there we go. He might ask me to leave, you know, not present my paper or something. And he bring me and he says, you know, we looked on the schedule and you're leaving before the award ceremony. And, you know, I had done that on purpose because usually I don't get awards. Usually I just get a kick in the butt, you know. So he said, oh, well, you know, we would like you to stay for the award ceremony. I'm like, why? He said, well, I'm not supposed to tell you, but your paper in the peer review passed for the best paper award. And I was in shock. Am I on the same planet? Did I hear this right? And I was like, oh yes, I'll change my plane ticket. And so, you know, I think it won this award, although it's upsetting many other physicists, because it's so simple and it's elegant. It describes the atom in a very radical but elegant way. And we're going to look at it today. So let's begin. Let's see. Okay. Barcelona. Wonderful. So, you know, I'm going to run you through. How many here have seen my DVD? Ah, I see. So I'm going to run you through the basics a little bit. You know, even if you've heard it before, stick with the process because it's always good to hear it again, and I'm going to give you a little more details. This started when I was fairly young. I was about 9 years old. Actually, it started earlier than that. I had all sorts of esoteric experiences when I was very young, you know, between the age of 5 and 7. I had many esoteric experiences, and I was an unusual kid. I didn't fit in very well the schooling system. I was not doing so good because I was living in this. I had this whole other world that I was interacting with, and so when I was sitting at school, you know, for hours and hours, I was spending a lot of time in this other world, and I wasn't paying attention much. And that didn't go so well, you know, in school. And but you know, when the teacher went to the blackboard when I was 9 years old, and he said, today we're going to learn about dimensions, then that caught my attention. Because I had all these other dimensions going on, so I thought, oh my God, adults know about these? And I thought, oh, he's going to talk about all these other worlds and all this. I'm like, I don't know any adults that know about this. And I thought, wow. And then I was so disappointed because it wasn't that at all. What he did is he made a little black dot, a little white dot on the blackboard, and he said, this is the first dimension, dimension 0, and it doesn't exist. And from that moment on, I knew I was going to fail that class. I knew I wasn't going to do so good. Why? Because I was sitting in the back of the class, and all the way from the back of the class, I could see the dot. So if it didn't exist, how could I see it? How could I experience it? I'm there, I see it, it must exist. And then he did something remarkable. He took a bunch of dots and put them in a line and said, that's dimension 1. And it still doesn't enclose volume, so it still doesn't exist. And then he took 4 of those lines, put them together into a plane and said, the plane is 2-dimensional. It is the dimension that your comic strip books live in, and it still doesn't exist because it doesn't enclose volume. And I could see all the other kids in the class were very crushed that their superhero didn't exist. And then he took 6 of these non-existing planes, put them together into a cube, and said, the cube encloses volume. The cube is the 3rd dimension, and that one exists. And then I was really confused. Because if you have a dot that doesn't exist, that makes a line that doesn't exist, that makes a non-existing plane. I don't care if you slap 300 million non-existing planes together, you still don't get existence. In this case, all you have is non-existence to the 4th. Non-existence 4 times over. So, I was coming back from a physics conference once with a very, very, a famous mathematician. And he was having a really hard time because he was sitting beside me in the plane coming from Georgia all the way back to California. And so that's a long flight, and he had me on one side and, 37,000 feet on the other. And so he was stuck. And I asked him, we were discussing space and time, and he was saying that, space and time is flat on long cosmological distances. And I was saying, you mean like a 2-dimensional plane flat? And he says, yeah, like flat. And I'm like, okay, well, what I would like to know is how thin is flat? How thin is the 2-dimensional plane? And he looked at me and was like, oh, scruffed. And he said, well, it's infinitely thin. Okay. Now we're getting somewhere. And so, when I was coming back from school after that lesson, I, was in the bus, and I had this long bus ride, and it was an hour and a half because I kept on getting kicked out of the schools closer to my home. And, I was furthering my education that way, and that day I had all this time to think, so I'm thinking about this, and I'm thinking, wait, how do I solve this? I need to know what a dimension we live in. What is this thing we're living in? I couldn't go one more day without knowing. I had to figure it out. Now, I didn't know that many philosophers and mathematicians and many people had worked on this riddle, had worked on this problem. I was just 9 years old. I thought, hey, I want to solve this before I get out of the bus. I think the universe had pity on me. Otherwise, I would still be in the bus turning in circles, you know. And I turned out that, you know, Buckminster Fuller, you know, a famous geometrist and engineer, had worked on this problem. You know, many philosophers in ancient time had worked on it. But for me, sitting in that bus, there must have been a fundamental solution to it. And I thought about it, and I closed my eyes when I was thinking, and in my mind's eye, I rose above the bus. And as I rose above the bus, I saw the bus becoming a dot. And as I rose further, I saw the city I was in becoming a dot. And as I rose further, I saw the earth becoming a dot. And I rose further and I saw the solar system becoming a dot. And I rose further and I saw the galaxy becoming a dot. And I thought, oh, it's dots all the way up. And then I flew back into the galaxy, I flew back into the solar system, I flew back in to the city I was in the bus I was in, and I opened my eyes and I looked at my hand and I thought, I wonder what that's made of. And I closed my eyes and I flew into my hand, and in my mind's eye I saw that it was made out of millions of dots we call cells. And then I flew onto the surface of one of those cells and I looked really closely, and all of a sudden it opened up and there was billions of little stars, little atoms, right? And then I flew onto one of these atoms, and sure enough, what was in the middle of it? A little dot. And then I flew into that one, there was another dot. And I thought, oh my God, it's dots all the way down. And that's when I realized that the only way to solve this riddle is to come to conclude that the only thing that exists is the dot. The exact contrary of the current axioms for our dimensions. Why is this important? Because, you know, all of the math, all the physics we're writing, most of the physics we're writing to describe our world are based on these axioms of dimensions. And if they were not quite complete, if they were a little bit wrong or a little bit skewed, then the answer we would get would be a little bit skewed. And then if we took those physics and we extrapolated philosophy from it, then those philosophy would be a little bit skewed. So it was really important to me. And I got really excited. I opened my eyes. I was in the bus and I looked at people and I could see they were made out of dots that were made out of smaller dots and smaller, billions of them. And I was like, wow. And everybody seemed to glow a little bit. I was having this moment, you know. I'm sure you've had moments like that. And you know how it is when you get those moments, the first thing you want to do is tell someone. And you know usually how that goes, right? You get that look like, huh? Did you take your medication this morning? And so when the bus got to my place, I ran out and I went home and I waited for my mom to come back from work. And when my mom arrived, I'm like, Mom, I figured out something at school today. And she was like, oh. And it's like, that was the first time she ever saw me excited about school. She's like, oh my God. I'm like, Mom, I learned about dimensions today and I think they're wrong. Oh, the look of despair in my Italian mother, you know. There's a force there that has not been calculated in physics yet. She looked at me and she goes, oh no, and I'm like, Mom, you're made out of dots that are made out of smaller dots that are made out of smaller dots to infinity. You got infinity in every dot that you're made of, Mom. And she was like, really? Yeah, Mom. She goes like, I just worked for 8 hours right now and I really don't feel infinite. And if you answer that at school, you're probably going to fail. So, she had made a very important point. If you have finite system and you have infinite division, how the two relate? If you have infinity and finite system, how do the two relate? If everything is infinite, how come everything is not falling into itself? How can you have distinction? How can you have boundaries, condition, right? So I had to think about that. So I thought, oh, I better stop talking about this because, you know, I gotta find a solution. And so I thought about it for a very long time. By the age of 11, I learned to meditate. There was a young master of meditation from India that taught me how to meditate. It was important for me because I was quite discouraged by that time with the human species. I was ready to exit. And I learned that there was a whole internal relationship, that maybe there was a whole internal world to discover, that my senses might not just be outside myself, but I might have senses that are going inside myself. And I thought, maybe there's a solution there. I didn't know at the time, but this difficulty between infinite and finite system is a fundamental chasm in our society. It has separated our physics, for instance. We have physics for the big stuff. Einstein field equation. It deals with galaxies, universes, you know, stars, planets. And it predicts that the space-time curve in a continuum fashion towards singularity, towards infinity. And then when we look at the atom, we have another set of physics. And those physics are quantum theory that predicts quantum numbers, finite linear structures. And the two don't agree. But you know, this chasm between infinity and finite system is even bigger, much bigger. You can see it, for instance, between the spiritual people and the scientific people. Spiritual people have a tendency to think in infinite amount of possibilities. Infinite continuum. Infinity is everywhere. And scientific people tend to think in finite, closed system, analytical solutions. Right? And so, commonly, the two don't agree. The chasm is even deeper. You can find it between male and female, men and women. Women have a tendency to think in infinite amount of possibility, continuum. Oh yes, honey, I can handle this 25 tasks, no problem. I'll just, you know, multitask the whole thing. And males typically are trying to analyze a closed system and then, you know, fundamental, you know, pieces at the time, and actually, honey, I'm busy with one thing. Don't disturb me. Right? And so one has infinity continuums in mind, the other one has quantum functions in mind, and it can happen that the two don't agree. Thus the rate of divorce, you know. And so, how do we reconcile the two? How do we put the two together? So, I'm going to show you in very simple geometry that the two agree with each other. That actually the two are complementary, that you can't have infinities without finite boundaries, and you can't have finite boundaries without infinities. We'll start with a circle, and we'll say that this circle defines a space, a finite space. And remember here, that circle could be a sphere, right? It could be a sphere that defines a space. And inside it, I'm going to put an equilateral triangle. Now, that triangle in a sphere could be a tetrahedron, right? So, a tetrahedron is the fundamental geometry, Platonic geometry, three faces with a triangle base. And we could say that the universe has spin, right? Everything we see seems to have spin and is polarized. So if it's polarized, then there should be a reverse triangle. Now, you know, interestingly, for the people that are interested in that section of the lecture, right away we have a symbol that's found in many, many different ancient cultures all around the world. Now, notice when I polarized the triangle, what happened? Right away, I defined a new set of boundary that's exactly the same geometry I started with, but at the next scale, at the next iteration. I can polarize that, and now I've done it again in the next scale over. It's very important that you understand that each of these boundaries define a very specific coordinates in space-time. That is, that the center of each of these boundaries is actually on its own very specific coordinates. Although it's part of the whole system, each one is a complete individual because it observes from its own very specific perspective in which no other boundary can observe from. You all following this? So, I polarize that. And now I get even smaller boundaries. And I could continue to do this and get smaller and smaller and smaller and smaller and smaller and smaller boundaries. In fact, if I give this geometry, if I give this program to my computer and I ask it to keep doing boundaries and then zoom in and then keep doing boundaries and zoom in and do boundaries and zoom in, it would continue to make boundaries to infinity and beyond. However, I would never, ever, 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 ever exceed that first boundary that I started with. I would never come out of it. I would continue to divide within the context of what appears to be a finite space. Now, remember, each boundary defines a very specific set of coordinates from which it observes the universe from, right? So each boundary represents a very specific set of information. Each boundary thus represents a very specific set of energy. And so, if I can divide to infinity within the context of a finite space, that means I could have infinite amount of information inside the boundary of a finite space. Infinite amount of information. Why is this important? It's important in many different ways. It's important in philosophy, it's important in spirituality, it's important in physics. Why is it important in physics? Because if the mainstream scientific community understood this, we would stop building accelerators. Right? Not so long ago, the scientific community got their first microscope, and they saw the cells at the biological level, and they said, oh my God, cells are so small. They must be the smallest thing the universe does. And then we had atoms. We realized that cells are made out of billions of atoms, and we went, oh my God, atoms are so teeny. They must be the smallest thing the universe does. And then we discovered that in the middle of atoms, there's a teeny weeny little beady little dot. Protons and neutrons, and we said, oh my God, those are so teeny. They must be the smallest thing the universe does. And then we start to scatter, with building accelerators, colliding atoms and getting smaller chunks and smaller chunks, a zoo of smaller chunks, and every time we thought, oh, this has got to be the God particle, it must be the smallest thing. And every time we had to build larger and larger and larger and larger accelerators so that we can collide atoms at faster and faster and faster rate. Now we've built the largest accelerator ever built, and we've reached practical limits. The Hadron Collider. 17-mile long, Every time they turn it on, things go wrong, because it's one time the coils ripped off the anchor, and went flying 17 miles and embedded themselves in the detectors, and then the whole thing flooded with liquid helium, and they had to evacuate all of CERN, and, the thing is huge. I'm amazed when they turned this thing on. I thought that all of Europe was going to dim, Honey, shut down the washing machine. They turned it on again. So, we've reached practical limit. But if this was understood, then we would understand that we can keep colliding atoms into smaller and smaller pieces. We're not going to get to the end of it. That there's infinite amount of division possible, so that what is important may not be if there's a fundamental particle, but if there is a fundamental pattern of division. Maybe there's some fundamental geometry that divides the space. Maybe that is what we should be looking for. Because if we understood the pattern of division, now we would understand the fundamental key of creation, the fundamental key on how the universe creates the complexity of our world. And that could be useful. So, I was thinking about this, but you guys think about it as well in terms of philosophy. I mean, first of all, if there's infinite amount of division in each boundary, that means that each atom that you're made of could have infinite amount of information in it. So that means that within yourself is infinity. That has large consequences in your understanding of yourself. Did you think of yourself as an infinite being? I mean, not in a spiritual way, in your material world. And that kind of leads to this understanding that maybe, just maybe, you have this infinite potential. But when you think about it, if you can be divided to infinity, what are you dividing? Maybe you're dividing the space. So let's do a little mental experiment. I'm going to ask you a question. If you wanted to find something that connects all things, what would that be? If I give you the whole universe, and I say to you, find me something that connects all things. You know, because a lot of spiritual people nowadays, they say, oh, don't worry, we're all one. Oh, it doesn't matter, we're all one, right? Well, how? How are we all one? It's not apparent. You seem to be over there and I seem to be over here. How are we all one? So if we wanted to say, okay, if we're all one, there must be something that connects everything, what would it be? If we had to think about it, what would we find? The only answer you could come up with, the only thing you could point to me and say, that is what connects all things, is space. Why? Because space is everywhere. It's between galaxies, between quasars, between stars, between, planets. It's between atoms, it's between cells, it's between atoms. In fact, if you take the densest atom, the densest molecule, like diamond, and you grew one of the atoms in the diamond molecule so that it becomes an orange size, then the other orange, the other atom would be 2 football fields away. That is how much space there is between things. Atoms don't touch. Do you realize you have never touched anything? Nothing. Nothing touches. If things started to touch, if the nuclei of atoms started to touch, you would have fusion. It would be a problem. In fact, when you so-called touch something, there's a lot of space. All there is interaction between electromagnetic fields bouncing off each other. Nothing is actually touching anywhere, at any point, at any time. And then when you look inside the atom, what you find? The atom is 99.9999999% space. All of the material world you see around you, everything you're looking at, your body, everything is 99.9999999% space. It's mostly space. With a little teeny little wiggle we call magnetic component, magnetic moment, a little wiggle, 0.0000001%. This is what we pay a lot of attention to, the wiggle. When I realized that early, I thought, oh, maybe we're paying too much attention to the 0.00001%. Maybe we should pay attention to the 99.9999999%. Maybe the material world is just a function of the space itself. Maybe space just divides itself, and where it divides, it wiggles a little bit, and we see it as reality. Maybe it's not matter that defines space, but maybe it's space that defines matter. So, can you experience right now your spatial self? All that space that you are you aware of it? Or are you only aware of the 0.0001%? So, it started to make sense to me that maybe space is the function, is the source of all the material world. It's everywhere. It would be able to connect all things. It would be connecting everything. Everything radiates into the space. So the space would know what everything is doing. It could be the organizing agent. Because in current physics, there is no space anywhere in our understanding for self-organizing systems. Meaning, general relativity or special relativity or quantum theory does not predict biology. It doesn't predict us with all of our complexity. It doesn't even come close because it actually says that it's all random. But if it was random, would it be possible? The complexity of one human being, if I took all the DNA in you right now and I put it end to end, I can wrap it around the world 5 million times. That's compactified inside of you right now, making sure that everything is working properly. In a very, very complex way that cannot be reproduced easily. You're shedding 1 million approximately cells a second. Like you're moving cells and you're dividing cells to make up for the cells you're shedding. And when you're dividing cells, the cells know what to do. They divide in the correct order. So that your liver cells continue to make liver cells, and your heart cells continue to make heart cells, and your brain cells, everything continuously knows what to do. It knows how to differentiate. Because if it got confused about that, even for a few seconds, or a few minutes, it could be a problem. If your toe cells start to make nose cells, and your nose cells make toe cells, It would be very uncomfortable. In your shoes, I mean, you know. So this system is self-organizing, and there's nothing in biology, there is nothing in physics, there is nothing in chemistry, there is nothing in our science that explains how. And in general, scientists try to avoid this issue. Why? Because when you start talking like this, the tendency is that religious beliefs come in. You know, somebody says, oh, it's God. It's God that's doing it. He's organizing everything. But what is God? Well, when you think of the vacuum could do the job. Space could do the job because it knows what everything is doing. So let me give you a small mathematical example. Do you guys all have Rubik's Cube? Yeah, you have those, right? So, if you take a Rubik's Cube and you give it to a blind person, which is not a very nice thing to do, but you ask him to order it, and the person is able to move a move every second, you can calculate in probabilities how many moves the blind person has to do to go through the probability of ordering the Rubik's Cube. And if this blind person is like Superman, you know, and he can continue to move the cube, one move every second, you can calculate, and the answer would be past 14 or 13.7 billion years since the Big Bang. Actually, it exceeds the Big Bang by billions of years. Because the blind person doesn't know if they're getting closer or if they're going further from the solution. But if you tell that blind person one simple piece of feedback, yes or no, every time they move, yes, you're getting closer, no, you're getting farther, then the blind person will order the cube within 2.5 minutes. Billions of years are 2.5 minutes. And biology is much more complex than a Rubik's Cube. Much more complex. So, there must be an organizing agent. Is there a possibility that this organizing agent is actually a function of the space itself? Not some God sitting on a throne with a pair of binoculars. If you're a Christian, he would have a baseball bat, you know, in case you sin. Now, is that the case? Maybe the vacuum can do the job. Maybe the vacuum is not empty, but maybe the vacuum is full. This is something I concluded to very early. Is there any evidence that it's full, though? You know, I did a lot of this research living in a camper van because I was independently studying that allowed me to have my own thoughts. And so I had to self-finance. I was a professional skier for many, many years, professional climber. And I had to finance my own research. My budget was $2,500 a year. And most of it went to gas, so I didn't eat much. And, you know, eventually I got my first sponsors. And my first sponsors said, well, we'll help you. We'll pay rent and give you a little food. But you have to Go to physics conference, the one we picked. So I went for it. I wasn't so happy because I already had some difficulty with the physics community. But I went to this conference in Georgia Tech in Atlanta, and you know, I brought this book. It's called Gravitation. It's kind of the Bible of relativistic equation. It's written by Wheeler, Thorne, and Mesner. It's the foundation of general relativity. And you can see it's quite a thick book, so you know everything you need to know about gravity when you try to pick it up. And in the middle of the book is this illustration at page 719. So I was in this conference, and I kept on asking fundamental questions, which was annoying a lot of the people in the conference. It was a small private conference with the director of the physics department there, other physicists, other mathematicians. And I was attempting to go back to the foundations of physics, and in advanced physics conferences, that's not really allowed. You know, everybody there has accepted the fundamental of physics, and you're not supposed to be rehashing it. You're supposed to be going into for 240 dimension of Calabi-Yau and superstrings and, very complex math, and you're not supposed to go back to the basics. So I kept on asking basic questions, and that was annoying everybody. I can have that tendency. But, at one point I said, you guys, I need to stop everybody because I have this question. And they said, okay, what's your question? And I said, well, I opened the book on this page, and I said, if I understand our universe as we describe it today with our equations, the example we give is a balloon. The universe is expanding, and we have little pennies glued to it. The pennies represent galaxies moving away from each other as the balloon expands. Well, I am a little confused because I said to them, I've been looking in all these physics books. I've been studying physics for a while now. I look everywhere. I can't find the equation. Can you guys show me where the equation is? Because, I might have missed it. I'm sure I missed it. Then I'll shut up if you can show me where the equation is. And they said, what equation? I said, I want to understand who's this guy. And, I got a different reaction than this. The room got very quiet. There was one of the students, PhD students, in the end of the table. He was drinking coffee and he went, And I could see the director of the physics department started to have a little sweat on his forehead because I think he thought I was going to say God, And he was like, oh no, don't say the word God in the physics department in front of my students. Oh. And I said, listen, let's draw the rest of the guy. If we draw the rest of the guy, notice that when the balloon expands, then the lungs must contract. For every action, there's an equal and opposite reaction. One of the first laws of physics you learn when you're a kid, right? Conservation law. Recently, I had an argument. Well, it's not really an argument because I didn't even bother answering it. Blog on the net. Saying, oh, he's confused about that. Let me give you another analogy. They said, the universe is like raisin bread. I was like, really? Raisin bread? And and the raisins are the galaxy, and as the bread expands, the galaxy move away from each other. I'm like, oh. And then he said, you see, no need for conservation law. I'm like, really? It is the nature of the bread to expand. Wow. This guy needs cooking lessons. I hope he's not doing the cooking at home. Because if you just put flour and raisin and water together, it's just going to sit there. You need an agent to make it grow. You need, yeast to make it grow. Yeast is a chemical reaction, is thermodynamic as well. It produces energy. You need energy for that thing to expand. Plus, you got to put it in, you got to put it in an oven, and never mind that you need a cook to make the bread. So, what am I talking about here? What I'm saying is that in the balloon is pressure pushing the balloon open. There's compression of air in order for the balloon to expand. There is an energy potential inside the balloon that's making the effect occur. And that part is not being understood. And the reason, because of this misunderstanding, most of our physics, most of our understanding is all about expansion, exploding stuff. Right? It's the male approach to the universe. Oh yeah, we get something that's highly explosive, we put it in a cylinder, there's a piston, we explode it, and we push a piston, and it turns the wheel, and it's like, yeah, let's blow some shit up, bro. We can blow stuff up. Expansion, radiation, it's all about that part of the equation. Nothing, very little is paying attention to the compressive part that must be there in order for the expansion to happen. Like our ideas of the most advanced technology for space travel, the most advanced thinkers on our planet work on these things, the engineers, is, for space travel, we make this big phallic symbol. Oh yeah, man. And then we put a lot of fuel in there, a lot of explosive thing, male approach to space travel. Oh man, we're going to blow some shit up. It's going to go up, bro. It will go up. A little too much testosterone. And then we put a little capsule on top of this cylinder, right? We find volunteers. We put them in the capsule. And then we light the bottom, right? Stand back. And then a few miles up, a little ejaculation. Poof. Only a few minutes later. The male approach to the universe. But in order for that fuel to be so reactive, in order for that fuel to be so powerful, it must have had compression of energy into it. It was in the earth, compressed. It was being energized. Where did the initial power come from? Our approach to the universe is that it all exploded into existence. But nowhere in our physics do we say where the energy came from to produce the explosion. Where did that come from? Instead of the radiative side, the general active side. I don't know if that translates very well. The centripetal side instead of the centrifugal side. The part that goes to the middle, the feminine aspect of creation, the part that creates, the part that nurtures, for the radiation to be able to occur. Where is that part? So, if this is true, then space cannot be empty. Space, if space is the general active side, if space is the part that generates all of the explosion, if space is the source of matter, then space has to be full. Is there evidence that space is full instead of empty? Yes, there is. In that same book is this quote. When we look at the quantum level, present-day quantum field theory gets rid by renormalization process of an energy density in the vacuum that would formerly be infinite, if not removed by renormalization. Let me say that again. Of an energy density in the vacuum. You know, usually when you think of the vacuum, you think of it as empty. That would formerly be infinite if not removed by renormalization. Removed, the key word. Why is this? It's because when you look at the atom, it looks like a little oscillator. And then when you try to figure out in the oscillation what is, you know, the smallest oscillation of the system, the smallest level of energy, you find that you can keep dividing and keep dividing and keep dividing, so you get infinite amount of energy. The vacuum structure inside the atom is oscillating with infinite amount of energy. So you would ask, why does it look like the vacuum? Why does it look like empty space if it's infinite amount of energy? Well, maybe it's because infinite amount of frequencies would all cancel out. And that would appear to you as nothingness. But where it doesn't fully cancel out, where there's a little bit of organization, then you would see it as the material world. Do you guys follow this? So, all of a sudden, the material world is a function of the oscillation of the space itself. It's just a beady little part of what's actually there. It's like thinking of the vacuum as full, and wherever it's leaking a little bit, we see it as matter, the material world.
There's no guru, there's no master, no savior. You yourself are the teacher and the pupil, you are the master, you are the guru, you are the leader. You are everything. And to understand is to transform what is. To understand is to transform what is. To understand is to transform what is.
Well, how did they renormalize it? What is renormalization? Renormalization is a way to cut the number. In physics, there's two kinds of infinities. One infinity is an infinitely small number. When you find an equation that gives an infinitely small number, you can discard it. Because it's a very small, thing, so you can, not pay attention to it. However, there's another kind of infinity called nasty infinity in physics. And nasty infinities is when you solve an equation and it gives you an infinitely large number. When you get an infinitely large number, then you can't just say, I'm going to ignore this. And so that's why it's called nasty. Although current physics has been ignoring what I'm going to show you for almost 100 years. because it was almost 100 years ago that they found that the density of the vacuum is infinitely dense. So when they do that, when they find infinity like that, what they try to do is find a constant to cut the number so they get a finite number. So in this case, they use the Planck's distance. 1.616 multiplied by 10 to the minus 33 centimeters. It's a very, very small number. It's the smallest thing, current physics thing, the universe can do. Meaning that 10 to the minus 33 centimeters, which is a point with, 32 zeros and a 1, right? Is very, 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 very small. And it's calculated using the Planck's constant, using gravitational fields and electromagnetic fields. And it says that it's the smallest oscillation, the smallest vibration the universe does. The smallest teeny weeny thing. And you can think of it as a photon going through itself. How long of a wavelength that would be? How many centimeters that would be? So they took this and they said, hey, that might be my mom. And she's like, you're talking again? Do you ever stop talking? So what they did is they took a centimeter cube of space and they said, how many of these little vibrations can we stick in there? That will give us a finite number of oscillation in a centimeter cube of space. We'll have a finite number for the density of the vacuum. So they put all those little oscillations in there and calculated how much they would weigh. What's their mass? Each one has a mass of 10 to the minus 5 grams. So now you can get a density. And the answer is 10 to the 93 grams per centimeter cube. 10 to the 93 grams per centimeter cube. That is a very large number. That's 10 with 92 zeros. Okay? You all notice in your bank account, when you add a zero, it's really good. Right? If you have like 4 zeros and you add one, it's like, oh, that's good. And then you add another one, it's, oh, yeah. Then you add another one, it's like, oh, now we're talking. Right? So it goes up pretty quick. Like imagine you got like some 50 zeros and you keep adding. Imagine 93 zeros. Oh. Let me give you an example. If you took a centimeter cube of space and took all of the stars in the universe, every single atom we see out there, and you squished them all into a centimeter cube of space with this huge trash compactor, Imagine how dense that would be. All the universe in a centimeter cube of space, like, What would be that density? The density would be 10 to the 55th grams per centimeter cube. You would still be 39 orders of magnitude off. Less than the density of the vacuum. With the whole universe in a centimeter cube of space. So, the vacuum density that you're made of, that all of your atoms are made of inside your body right now, is a lot of vacuum. It has this incredible, infinite amount of energy, or extremely large at least. And you know, you may have access to that. People tell me all the time, I have a hard time visualizing infinities. That's because people try to visualize infinitely big. And that is not very possible because you have limited senses outside yourself. You can only see a few miles out. You can only touch a few feet away from you. But internally, there is a possibility that you could have access to infinity, towards the infinitely small. This may be why some of the greatest masters that have walked the earth have been trying to tell people, turn your senses inward. Go towards the center. Go towards the vacuum. Go towards stillness. Because there you will connect with the foundation of creation. You will connect with, they might have called it God, the Bindu point, the infinite potential, and so on. You know, to take a few minutes every day to do this might be a good practice. Just to find that power, just to find that center at the center of your existence. So you might say, well, you know, these equations are crazy. You might say, I don't believe the vacuum is that dense. Maybe physicists are doing something wrong. Well, somebody like that thought like that in 1947 and said, hey, we need to be able to measure if this vacuum density is really there. Does it really exist? His name was Casimir. And in 1947, he calculated, how can I measure the vacuum density? And he came up with this idea. He came up with this idea that if you put two plates very close together, very, very close together, you will eliminate the long wavelengths between the plates, but not on the outside of the plates. So you should get a difference between the energy on the outside of the plates and the energy between the plates. They should get pushed together. I have a small animation you can see. Hello? There we go. You can see, let me play it again. You can see that there's little waves between the plates and there's a lot of waves on the outside of the plates. So as you bring the plates together, some of the wavelengths get eliminated between the plates, so you get an external pressure pushing the plates together. Well, when he did the calculation, you realize that in order for the plates to get close enough to eliminate enough frequency so that the vacuum could push the plate together, the plates would have to be microns apart, which is a very, very, very teeny distance. 1947, nobody could polish plate micron precision. There was no way to get two plates that close together. So it took until 1990 before we could get plates that close together. And when we brought the plates together, sure enough, they started to get pushed with exactly the force that was predicted by Casimir in 1947. This is a laboratory proof that that energy is really, really, really there. It's everywhere, and it's inside you. And since it's inside you, since it's the energy that makes you, you have access to it. And remember, those frequencies, these energy represent information. That means you have access to an extremely large amount of information. This starts to be able to explain many paraphysical phenomena that we see. You know, remote viewing. Obviously, if the vacuum connects all things and it's everywhere, if you go inside yourself, you can get the information of what's going on very far away from you. It starts to explain entanglement. Why particles interact. Like, for instance, new experiments were done when you can scrape a little bit of cells off the tongue of a person, put them in a petri dish, and keep them alive, and monitor their energy level and all this. And then you send the person away, and you put all sorts of devices on them to monitor, you know, the change in temperature, changes in brain frequency, and so on. And as they're going through their day, for instance, in this particular example, this lady during the day had an appointment at the doctor to get a mold removed. And everything was stable, both in the cells and in the data that was on the person, until she got to the doctor, started to get nervous, and she saw the knife that the doctor was going to cut the mole off with. When this happened, her vital signs, everything in her data, jacked up. And you can see on the graph, everything go up. And exactly at the same time, in cells that were 15 miles away from that person, the cells' data start to jack up at the exact same time. You can see the graph are exactly the same. So this starts to be understood because the vacuum connects all these things together. So with the help of Dr. Rauscher, Dr. Rauscher is a physicist that has been collaborating with me for now 6 years. We started to write a scaling law. And the reason why we wrote a scaling law, because when I was talking to Dr. Rauscher, she was saying, if this is true, if the vacuum is full and the vacuum is dividing to create our reality, then when we graph the objects in the universe on a graph, they should all start to line up. They should show organization. They should show that things are self-organized. And so we did this graph. This is the radius of the object. This is its energy level in hertz, frequency. And we started with the universe, the size of the universe and its energy level. Now, it is an interesting thing there. If you take the size of our universe and you put in the amount of mass we see in the universe obeys the Schwarzschild condition. The universe obeys the condition of a black hole. Did you know we live inside a black hole? I mean, when you look up at night, it's black. We know there's enough stars that it should be completely white. But when you look at our universe and you were to point a laser at it, the light of the laser would get curved by the gravitational field of our sun a little bit. And it would curve that light a little bit. And as it curves it, then the light would continue to go, and then it would hit another star, and it would get curved by the gravitational field of that other star. And then another one, and another one, and another one, and another one, and it would come back. Because there's too much mass in our universe obeys the condition of a black hole. Was that expected in my theory? Absolutely. Because if you can divide to infinity everything, then all you have is different scales black holes. All you have is divisions of the space, division of the vacuum. And in each division, you have infinite amount of mass. If you can divide the atom into smaller particles and smaller particles and smaller particles, and each particle has mass, then you can add all the mass, you will get a black hole. So, we live inside a black hole, so that would mean that all the things we see inside there, we are on the outside of those black holes. So what do we see there? We see the radiative side, we see the white hole part of a black hole. We call it a star, we call it a galaxy, we call it a quasar. Now I want to make clear, this is not the standard model. Just in case you were confused about that. Because this theory says there's a black hole at the center of our sun. It says there's a black hole at the center of our Earth. It says there's a black hole at the center of atoms. Well, when we start to plot all these other objects, so this is quasars, galactic centers, stellar objects, they all started to line up as predicted by my theory. We plotted even atoms and subatomic particles. This is the Planck's distance, 10 to the minus 33 centimeters. I'm getting a cramp in my toe from too much surfing. And so, this linear progression functioned perfectly, even including atoms, which are usually not included in the, in the cosmological sense. Meaning, here I'm crossing from Einstein's equation to quantum theory. They all seem to line up. So obviously, the two are related. Interestingly, if you take the microtubules, which is the little entities, they're the little structures that make up the surface of your cells. They're little tubes, they look like little wormholes. You take their energy level and their radius, they intersect the scale very, very close to its center. So even your biology is part of this scale. You are part of this incredible scale from extremely large, the universe, all the way to billions of times smaller than an atom. You're right there on that scale. You're part of that system. You're transferring information from the outside to the inside. From infinitely big to infinitely small. You're embedded into the structure of the vacuum. It's communicating with you, and you're communicating with it. You're part of that feedback. You're like an extension of space looking back at itself and learning about itself. That gives you a different sense of your responsibility. That gives you a different sense of your relationship to the universe. You're no longer just an insignificant little dot in the universe. All of a sudden, every single dot is crucial to the learning structure of our universe. We know that the electrons and positrons that makes up your atoms are appearing and disappearing into the vacuum. This is why there's uncertainty about where they are and where they're going. This is how the vacuum is informed. You're appearing, disappearing, appearing, disappearing, really, really fast at the speed of light. And when you disappear, you're the vacuum. You're informing the vacuum. And then when you reappear, you're experiencing the material world. And when you take your experience, you feed it back to the vacuum. And like that, the vacuum is feeding you back your experience. You are creating that reality. You all following me? Now, you will hear that in the New Age and in the spiritual groups. You create your reality. You'll hear it very especially if you're having a fight with your partner. You created this. It's very convenient in this matter. Well, that is only half of the equation. Because if there's a feedback, if you're informing the vacuum and then the vacuum is giving you back your experience, then reality is creating you as well. So you're creating your reality and then reality is creating you. Because you see, if you only have half of the equation, if you say you create your reality, which is becoming popular, even in the physics community, if everybody created their own reality, it would get very lonely. We would never meet. Everybody would be in their own reality. Going, where'd everybody go? Right? But we have a consensus reality. Because there's a medium that connects us all, that's making sure that there's organization between all interpretation of reality. So that when you think something, when you interpret reality, then you feed it to the vacuum, then it's modified by everybody else's experience, so that when it comes back to you, it's coordinated with everybody else. You guys follow this? Very important part. You can't forget that part. Otherwise, you could say, hey, I'm too hot today. Let's turn the sun down. And then the poor guy in Alaska is like, oh, it's cold. And so, there's coordination. So the concept, you all heard about the butterfly effect? The concept that a butterfly in Africa can bat its wings and produce a hurricane in Florida is not complete. It's not complete. The probabilities of that happening is very, 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 very low. Right? Because if every time a butterfly flapped his wings, there would be a hurricane in Florida, you would have Floridians in Africa with guns, going, stop doing that. You're upsetting a lot of people over there. No, it would take thousands, millions of butterflies batting their wings together to even produce a probability that a hurricane could be created from it. Otherwise, it's almost not possible. Huh? Because the whole morphogenic field has to have enough power to make a change. This is why I'm talking to you today. Because in order to make this change I talked about at the beginning of the conference, we must come together. We must gather our forces. We must all come to a different understanding together so that it becomes something in the morphogenic field that has power, so that it can make that change, so that the butterflies start to make a hurricane. And that is because we are all connected in this feedback loop of creation, in this feedback loop of learning. So never, ever, ever forget the second part of the equation. Reality is influencing you. The world is influencing you. As well, that will help you, because some people, spiritual people, said, you know what? I went to all the seminars, even Nassim Haramein, and I read all the books, and I did all the meditations, and I still can't manifest this blue Camaro that I want. What is wrong with me? Well, in order for you to manifest something significant, you have to overcome all of the other manifestations that are occurring from all the other reality. It has to coordinate. So when you're sending information into the vacuum, when you're sending information into the space, then when it comes back to you, it's always a little bit modified. It's not exactly as you would expect it, because if it was, you would stop learning. You would have manifested the ultimate reality for you a long time ago, and you'd be sitting there going, man, this is boring. I'm not learning anything. What is going on, right? The universe would end. But because the whole system is modifying everything all the time, when you feed it to the universe, it comes back to you a little change. And so you keep learning, which means the universe keeps learning. Okay. Well, you know, if you look at this graph, well, this graph is refusing to work. Let's see. You find that these two data points can be black holes. These actually can be black holes too. But you know, the atom in standard physics would not be a black hole. If you tell a standard physicist, oh, I saw this guy that says that atoms are black holes, he will say, not possible. So this is why I dodge a lot of tomatoes, you know. Because my reality has not quite caught up with the rest of the scientific community reality. Is the atom really a black hole? Is that possible? Well, I thought about it for years. I was looking for a way to understand how that's possible. Currently, standard physics would say no. It's not massive enough. It doesn't have enough energy. But then I realized, wait a minute. Remember this number, 10 to the 93 grams per centimeter cube? It has been completely ignored by the scientific community for a very long time. Actually, the standard answer to this number is it has no physical meaning. What? You mean the largest, most intense energy ever found has no physical meaning? How is it pushing two plates together if it has no physical meaning? So I started to say, wait, maybe they ignored this. And sure, they did. They didn't consider the amount of energy inside the nuclei of an atom in the vacuum fluctuation. They just left that out. So I said, let's see how much energy is inside the nuclei of an atom in terms of vacuum density. How much vibration of the vacuum is inside a proton, the nuclei of the atom. You all following this? This is where we're going to do a little math. You all ready? Not bad math, easy math. Okay, so I then took the radius of a proton and I said, how much volume is inside the radius of a proton? So this is 4/3 multiplied by pi multiplied by the radius square cube will give you the volume of a proton, a spherical volume. You all following this? And so the volume of a proton is approximately 10 to the minus 39 centimeters cube. So it's extremely small. It's teeny, teeny, weeny little volume, right? Very, very, very small. Like 39 zeros, you know, and a 9, right? Very, very, very teeny volume. And then I said, okay, so now if I take that volume, if I divide it by the density of the vacuum, I will know how much vacuum density is inside the volume of a proton. So you see, it's in grams, centimeter cube. The centimeter cube cancel out, it leaves grams. And that's 10 to the 55 grams of energy in the vacuum inside the proton is still present. Did you all follow this? That means that the vacuum density, there's still 10 to the 55th grams of vacuum oscillation inside the proton of information. Why was I not surprised for this number to come out? Because what is that mass? The mass of the universe. Why was I not surprised? Remember my statement? The vacuum connects all things. So that means that all the little oscillation of all of the protons in the universe experiencing the universe from their own perspective would have to be in each proton for the vacuum to know what everything is doing. So when that number came out, it right away mathematically proved that we are all one. That was significant for me because, you know, making a statement without an understanding of how that's true is not complete. But when you start to understand the mathematics on how that's true, now you've got something really powerful going. So in the paper I published, and that's why I was saying that paper was so radical, I thought I was going to get kicked out of the conference, not receive an award, right? Is because in that paper, when I make this equation, I put a very simple statement. This may be evidence that all protons are entangled. All protons are connected through the structure of the vacuum. And that's how the system can self-organize. Because the vacuum knows where everything is. So this, is a very large number. Do I need all this energy for the proton to be a black hole? No, because even this in the size of the universe is enough to make the universe a black hole. So I don't need anywhere close to that for the proton to be a black hole. So then I calculated what actually amount of the energy of 10 to the 55th gram is needed for the proton to become a black hole. Don't panic. This is called the Schwarzschild radius, or the Schwarzschild solution. Carl Schwarzschild was the first man to find a solution to Einstein's equation. When Einstein published general relativity, he didn't solve it. He just published the concept that gravity is not a force inside an object, but that gravity is the result of an object distorting or curving space-time. And when he published it, he thought, well, the equations are complex and all this. It's going to take a long time before we find a solution. But Carl Schwarzschild was back from the front. He was at war in Russia. And while he was sick, he actually solved Einstein's field equation. And it's called the Schwarzschild solution. He died 2 weeks later. But he sent the solution to Einstein just on time. And Einstein was quite surprised. He said, oh, wow, there's already a solution. But when you solve the solution, he said, oh, it produces a black hole. It produces a singularity. He didn't call it a black hole because that was coined later by John Wheeler. But it produced a point of infinite density. And he didn't like that part. He thought, well, maybe my equation breaks down there. We'll just take the weak curvature, not the high curvature. So this equation is used all the time to calculate gravitational fields in the universe, but they ignore the fact that it needs a black hole, it needs a singularity at the center for the curvature to actually occur. So it tells you what radius a black hole would be. Friends, this is R sub s, is the Schwarzschild radius, equals 2 multiplied by the gravitational constant multiplied by the mass divided by the speed of light square. So this, if you know the mass, the gravitational constant, you can solve this to figure out what would be the radius of a black hole. Like, where does a system would reach the condition of a black hole? But in this case, I know the radius. What I'm trying to figure out is what mass I need out of 10 to the 55th for the proton to be a black hole. So this is the equation, just like this. Here's the radius. This is the gravitational constant, so 2 multiplied by the gravitational constant. The mass, I don't know what it should be, and this is the speed of light square. So I got to change the equation around so it equals mass. You all following this? So now I take the speed of light square, I bring it on top. The radius is over here. And I bring the the gravitational constant on the bottom, and that will give me the mass. And the answer is 10 to the 14 grams proton. And now I can calculate how much of 10 to the 55th gram that's inside the proton did I use to make it a black hole. The percentage is 10 to the minus 39%. A very, very, very teeny weeny little teeny beady little amount of the vacuum becomes coherent to produce all of the atoms in our universe. Very teeny weeny amount to produce all of the material world. So what I'm saying in that paper is that maybe just a teeny weeny amount is necessary of coherency, not randomness. Coherency occurs in the vacuum to produce the material world. Well, you know, this is remarkable. Again, you know, that number keeps coming out. Did you all notice? 10 to the minus 39, or 10 to the plus 39, 10 to the plus 40. This has to do with Dirac, which was a famous physicist. It's called the large number hypothesis. Dirac noticed that this large number keeps coming out everywhere. And he made a hypothesis that there's a relationship between the atomic level and the universal size that relates this large number. So, you know, this is all nice. It's pretty, it's simple. But if you ask a physicist, a quantum physicist especially, it will tell you that it is wrong. Why? Because 10 to the 14 gram proton is actually in the standard model, they say it's 10 to the minus 24 grams is the mass of a proton. So you will say, oh my God, you're off by 10 to the 38 grams. See, again, that number. Very close, you know, 10 to the 38, 10 to the 39. This is what happens to me when that happens. Has he gone insane? I'm 10 to the 39, 10 to the 38 orders of magnitude off. Oh! What am I gonna do? You gotta remember, I'm looking at the mass inside the vacuum of the proton. So, luckily, since I've been meditating for a long time, the Buddha comes in and says, stay calm, it's okay. The key is the strong force, dear one. What is the strong force? Well, almost 100 years ago, we discovered that protons have charge, right? That's why we call them proton. They're positively charged. And that charge would repel them from each other. If you take two magnets of the same polarity and you push them together, they will repel, right? So when they found this, they said, you know, the repelling power of, it's called the Coulomb force, is very, very strong. How can the atoms stay together? Atoms should have never formed. And so to solve this problem, they said, oh, well, gravity is not strong enough because at the time, they didn't have black holes, right? So they said, we're going to invent a new force. We'll call it the strong force, because it has to be very strong. In fact, it would have to be the strongest force in the universe. And they assume that it was there because the atom is together, so there must be a force squishing it together. But they give no physical understanding, no physical meaning, no source for that energy. They put the strongest energy in the universe in our equation without saying where it came from. You know? And then they said the force is mediated by gluons. The glue. Okay. One way to do physics. I call it physics as you go. You got a problem here. You just put in the strongest force in the universe. Don't worry about it. You calculate the mass of the universe. You're missing 96% the mass of the universe. Oh, you just invent dark matter. You put it in there. Oh, look, the equation works now. Don't worry about it. Right? So they invented the strong force, and they said, they calculated how strong it would have to be, and they made it exactly the strength it has to be to compress the protons together. And then a big problem occurred. Later on, they discovered that there was quarks, little smaller particles inside the proton, in a teeny radius that are charged, and they said, oh, now these things are compressed into a smaller radius again. We need a stronger force than the strong force. But they couldn't really call it the strong force. I mean, that just doesn't look good. So they came up with another scheme. The color force. It's nice, it's artistic, you have colors. And they said, oh, the color force will make the color force infinitely strong. Like that, if we find anything smaller, now we have infinitely strong force to deal with it. But think about it. If you have an infinitely strong force compressing into a small volume, squishing, confining into an infinitely small or a very small volume, what does that make you think of? A black hole. That's right. How do you say black hole in Spanish? Awareness? I'm not going to even try. I'm going to have to tap into the vacuum of Spanish language. And so, this squishing was not given any source. Imagine throwing in your physics an infinitely strong force, but not saying where it came from. So obviously, when you ask a physicist how strong is the strong force, they don't really have math that tells you how to calculate it. They have latex QCD, but there's no comprehensive answer. So they tell you a comparison to something they know, which is gravity. So they say, how strong is the strong force? They say, well, if gravity is 1, guess what? The strong force is 10 to the 38 to 10 to the 39 times stronger. You see, the difference between the standard model and my model is that in my case, I accounted for the energy necessary to confine, to hold everything together. They just threw it in with no source. So in my case, it's gravity that's doing the job. That's holding everything together. Gravity in standard model is the weakest force of the universe. In this model, gravity is the strongest force of the universe. It holds everything together. It is the vacuum curving, it's the vacuum spinning towards singularity. That is at the center of existence, the force that holds to the center, the mother that holds the child. And so, you know, I knew that this would not convince a physicist. So what I did is I wrote a scaling law. And in the scaling law, actually in the paper, the scaling law has more data points. And the paper that's on the net is not complete. It's a draft paper. I'm not putting the complete paper on the net because it hasn't been published yet, so I'm waiting for it to be published in the journals, but then I'll put it on the net. But we put data points. Here's the universe. And so this is the log of the mass against the log of the radius, right? Mass and radius. And I said, okay, forget equations. If I'm wrong, my proton is going to be completely off, and the standard proton is going to be correct. So, you know, from the Planck's mass, which is teeny, 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 to the universal size, I put galaxies, I put quasars, I put the sun, even the Earth, pulsars, and then I put the Schwarzschild proton. Look at that. Perfectly on the line, right? Perfectly on the means of all these data points. And then the standard proton, completely off. Off in left field. This doesn't lie. This is fundamental. You can't just, you know, you can't debate this. This is just data. This is not some idea. This is not some mathematics. This is data. And so here, you can see that this is a problem. Why is it a problem? Well, a physicist will say, but why then, when we do experiment, we measure the mass as 10 to the minus 24 grams? Well, because when we measure the mass of a proton, we measure it after we knock it out of an atom. Right? Or we measure it far away from the surface event horizon of the black hole, where the gravitational field is weak. So what we're measuring is a frame of reference from our scale to the frame of reference of the proton, far away from it. So what I'm saying is that if you were measuring near the event horizon, you would find that it obeys the Schwarzschild condition, because that's where the vacuum is actually producing the proton. This is where the vacuum is interacting, producing the proton. You all following this? So it actually works. I think we're going to take a break now to get you a chance to use the washrooms and maybe get a tea or a bite. Thank you so much for this morning session. Thanks for your attention. Thank you. Thank you. We're going to have some fun this afternoon.
Understand it, go into it, to examine it, give your heart and your mind with everything that you have to find out, the way of living differently. But that depends on you and not somebody else. Because in this there is no teacher, no pupil, there is no leader, there is no guru. There's no master, no savior. You yourself are the teacher and the pupil. You are the master, you are the guru, you are the leader. You are everything. And to understand is to transform what is. To understand is to transform what is. To understand is to transform what is.
Radio Evolution, and Marco, and all the volunteers for doing such a great job in organizing this and being able to bring me here in Spain. So thank you, you guys. Thank you, everybody back there. Thank you. Doing an excellent job. So let's go back to our presentation. We're almost done with the math. Oh. Okay. So, did you all experience your vacuum self during the break? Remember, when you're eating, you're actually putting vacuum in. This, in one way, I'm not kidding, because this might be, there's Brahmins and masters that have now come forward that have not been eating for many, many years. And when I was in the van, I barely ate for years. And, there might be ways that you can bypass the material world and get in and pull the energy directly out of the vacuum, out of the structure of space-time. This may explain why these people can do that. But let's get on with the presentation. So now, after the scaling law, we see that, the difference in mass between the proton, the standard proton and the Schwarzschild proton is actually, the result of the standard model omitting to add the force necessary to confine them. As well, you can think of it this way, and that is that how is two protons that are mini black holes would interact with each other? So you can calculate the force between the two protons, two little black hole protons. And that force would be calculated this way in a classical way. So force equals gravitational constants plus the mass square over the radius square. And so here is the gravitational constant, here's the mass of the Schwarzschild proton square, and here's the radius square. And the result is a force of 10 to the 47 dynes. It's very strong. And so in this case, gravity is the strongest force. It holds the atom together. And when you've done this, then you can calculate how fast the two protons would rotate around each other. So their velocity, the first thing you have to calculate is their acceleration, how fast it would accelerate around each other. So in high school, you probably learned F equals ma, right? So here is A is the acceleration equals F over m. So we just calculated the force, we calculated the mass, that will equal 10 to the 32 centimeters per second square. So now you have the two protons accelerating around each other very, very, very fast. From that acceleration, you can derive the velocity. So V, velocity, equals 2 multiplied by the square root of the acceleration multiplied by the radius. We calculate, and the result is 10 to the 10 centimeters per second. Anybody recognize that number? That's the speed of light. The velocity of light. Actually, you know, when you do the full calculation, you get exactly the speed of light, which is really remarkable because it's a fundamental constant and it just comes right out, you know, out of the calculation. The exact speed of light, right out of nowhere. And it's really remarkable. You can now start to imagine, you can now start to realize that not only are you made of infinite little black holes, but these black holes inside of you are spinning at light, at the speed of light. It's very significant. You know, many masters have come and said, everything is light. Maybe that's what they meant. Everything is spinning at the speed of light. This actually may be why the speed of light is the speed of light. Yeah. And so, you can actually visualize that all of your atoms not only are little teeny black holes, but they're spinning extremely fast. You are a light body. And the reason I'm telling you all this is because, you know, many spiritual people have a tendency to think that in order to be spiritual, you have to escape the material world. And what I'm telling you today, what I'm showing you mathematically, is that the oneness, is that the infinite potential, is that the speed of light, the light body that you are, is not some esoteric thing, but is actually the material world that you're made of. That there is no separation between spirit and matter. It's all the same thing. It's a dynamic of the space itself. It's a dynamic of the vacuum itself. You need not escape the material world. The material world is your gateway to infinity and beyond. Because that separation between spirit and matter has created a large fraction, a large chasm in our society. You know, there's the spiritual world that says we don't need matter. Right? I get phone calls from people saying, you know, we don't need no stinking technology. I'm like, but you're calling me on your cell phone driving your car. And I have the physicist saying, you know, I was in a physics conference and one group of physicists from England came and they were a little bit in shock when they came to this conference because it was a conference in California, and instead of chairs, they had big, you know, exercise balls, you know. Because physics conference can be quite boring, and so people fall asleep. But when you were sitting on these balls, you could not fall asleep. But you can imagine, you know, the physics community that came from England, you know, when they walked in the room and they saw all these like 70-year-old physicists bouncing on the balls. Oh, we're in California. And I was, you know, a friend of mine was presenting about consciousness and physics, and, you know, one of them said, well, you know, our theory does not require consciousness. And I was like, do you realize you just insulted yourself? Of course it requires consciousness. You wrote it. You know. Right? So it's a problem because we got some people that say we don't need consciousness, we don't need spirit, and the other people are saying we don't need matter, and guess what? It's all the same. It's all one. It's this fundamental field that produces a learning structure in space-time that makes up all of the material world, which is an expression of the structure of space-time itself, learning about itself. This is why matter evolves. It doesn't just sit there and do nothing. It actually evolves. It moves together. It tries and it organizes in many complex ways and produces amazing, amazing worlds. So it's not separated, and that has to go away. The monks that says we don't need the material world have to come and understand the material world is spirit, and the physicists and scientists that say we don't need spirit have to realize that the material world is spirit. It comes together. What is spirit? Spirit is all of the information of all things present in everything. Right? Which I give you an equation to prove to you that it is so. So, the speed of light comes out. Remarkable. Think of yourself as this light body. You are a light body. Imagine, it's because from the frame of reference of your size, it's your relationship to size that's confusing you. Because of the size we are relative to the scale, we're sitting around going, you know, there's not much going on around here. Right? We're on a planet that's spinning, that goes thousands of miles per hour through space, that's going around the sun, and it's going thousands of miles per second through space, which is going around the galaxy, this thing we're hurling through space right now. Unbelievable dynamic is occurring right now. And we don't see it because from our perspective it's like, oh yeah, the sun came up, you know. Oh yeah. Kind of going slow, right? And then from our perspective, we see the atom, we say, oh, you know, there's not really much happening there. These things are black holes spinning at the speed of light. Super dynamic world that's embedding the structure of space-time. You know, we teach children that our planet is going around the sun like this, in a circle. That's not the case. We should never, ever, ever teach that to children. In my school, we had a sun. We had this little machine, this little device. We had the sun in the middle with the earth and the moon, and we had like a little thing we turned on the bottom, and it would go around like that to show us what the solar system looked like. Did you have that in your schools? This is completely wrong. That would be like saying to children that the earth is flat. It's not true. Why? Because our sun is moving through space at 3,000 miles per second. So as the planets are following the sun, they are making this huge spiral through space. And so after a year of the earth spinning around the sun, we're not anywhere close to where we were a year ago. We're millions, billions of miles away. Every minute, every second is different from the other because the evolution of the coordinates of the space-time manifold is constantly changing. We're never coming back to the same point. The information is constantly changing. We are, through this speed of light interaction of where the electron appears and disappears and appears and disappears, we are embedding information along that spiral on the structure of space-time, along that path. Can you all visualize that? And so that if you actually took the earth and you took you on the earth, your body on the earth, you could say that like we could follow that path through space and your DNA is actually embedding information on the structure of space-time all along that path. Do we have any evidence that DNA does that? Yes. It's called phantom DNA. It was discovered by the Russians. It was discovered by accident because there was a scientist that was doing a measurement in a spectrum analysis device, scattering photons off DNA, and he was taking measurements, and he went for lunch. He removed the DNA sample from the device and went for lunch. And when he came back from lunch, I think Russian people like to drink vodka. He forgot that he had removed the DNA strand, and so he continued his experiment. He continued to make measurements. And the measurements were coming out like the DNA was still in the machine. But the strand was not there anymore. So DNA leaves an imprint on the structure of space-time. Leaves an imprint of information on the structure of the vacuum. You are imprinting information on the structure of the vacuum. This is actually, according to me, why you have memory. Because if you had no memory, you wouldn't have time. Would not exist. Because you couldn't remember anything. So, actually, memory, which has not been identified in the brain, people are trying to figure out where memory is in the brain. A lot of scientists are trying to identify where is consciousness in the brain. I think Buckminster Fuller said it the best. He said, the problem with the current approach to science is that we have confused the telephone for the conversation. Right? The brain is the telephone. It is not the conversation. The conversation is the structure of the vacuum interacting. The chemistry that occurs in the brain, the electrical discharge, is a result of the structure of space-time interacting, not the source. And that's why, if, there is disturbance in our field, in our emotion, then chemistry starts to change in the brain. You can't just change the chemistry of the brain and assume that the problem, the emotional trauma and all this is going to go away, because that's still embedded on the structure of space-time. So using this, I've helped people that had serious trauma try to help them relieve that trauma. Because somewhere it's on the structure of space-time. And so since that actually connects right up to you, in your back actually, right? Since that connects right up to you, then you can have access to that structure along that path. This is actually how psychology works. You know, people say, oh, you know, you think of your childhood and try to have a new optic on your childhood, and that will, you know, relieve you from trauma. Well, that's because, although they don't know that, that's because you're actually changing the memory imprint on the structure of space-time. You can actually follow the information of you along that structure all the way back to your mother. That spiral goes all the way back to your mother, and that connects your spiral with her spiral. Where you connect with your mother, you can go towards your father's spiral, or you can go towards your mother's spiral. And then you can continue along that path. And then again and again. This is actually how, according to my work, genes keep information continuous. You know, in current biology, there's no explanation how genes carry all this information that produce the genetic pool. The continuous from a family to another family, you know, along that path. This is because the imprint is actually informing the genome structure. So along that path, you can actually go with your consciousness, and I've been able to help people do that, because if you actually understand the correct mechanics of that path, you can follow it, and along it, you can change your relationship to an event. You can change the geometry. So if there was an event that was traumatic, you can actually experience the event from a different angle. For instance, for canceling the event completely, if somebody did something wrong to you, you can experience the event from that perspective, from the person that did something to you. And there you're going to experience maybe their fear and their trauma and all this. And then that will cancel your experience, and all of a sudden, all of the information moving forward back to your present will change. And as a result, I've had people like have, you know, healing almost instantaneously on the spot. Release like trauma that has been there for the whole life. And as you change this, it's going to change it forward to your present, and that will change the information moving forward to your future, because now it's changed. And from that moment, you can change that information all the way back as well, because when you change it, it's going back in that spiral. Now you're changing generation of information throughout time. Your mother, your grandmother, da-da-da-da-da-da. Your father, your grandfather, da-da-da. You see? Because you are that very tip of the spiral You know, that very tip at the end of that spiral that goes generations and generations and generations till the beginning of time. So your responsibility, you've accumulated all this information from all of these generations. It's your responsibility to make it different. So, all this from... I got a little sidetracked. Sorry. But protons are spinning at the speed of light. So V equals C, the speed of light. Then from the speed of light, we can calculate the period. The period would be how long it takes for one proton to go around the other. Right? Like meaning in one turn. How long it takes for one turn to happen. So the period, or t, the time, will be 2 multiplied by pi multiplied by r, right? Because it's one circle, so pi by r, over the velocity, because it's going that speed for one turn. And that will give you 5.5 multiplied by 10 to the minus 23 seconds, which just happens to be the exact characteristic interaction time of the strong force. See what just happened? This is a measured value that we've done that shows that, you know, the so-called strong force that they threw in, they calculated, and then in laboratory they looked for how fast that strong force can attract another particle. So like if you throw an electron near a nuclei, how fast will it grab it? And that calculation is 10 to the minus 33. So that's in classical quantum theory, meaning in the standard model. Except that here, I got the same answer, but completely classically, with a completely different approach. So I'm getting the right answer with a completely classical model. No quantum thingy. Right? It's remarkable. Now we calculate the frequency. So that means like if it's going around each, it took 10 to the minus 33 seconds to go around one time. Then how many times does it go around in 1 second? Which is in hertz, right? So then that would be 1 over the time. And the result is 10 to the 22nd hertz, which is a typical measured value of the gamma ray emission frequency of the nuclei of an atom. So this is actually the decay of the atom. It comes right out from black hole protons spinning around each other. No quantum theory again. Very simple. You're getting the right answer with a very simple mechanical approach to the atomic world. And when I say simple, mechanical, no quantum theory, some people get disappointed. They're like, well, I like quantum theory. Because a lot of people look at quantum theory as like, wow, this is a theory that actually has a possibility for esoteric understanding of consciousness and all this. But I want to make clear that although this model is classical and mechanical, which is, Einstein didn't believe in quantum theory. He thought there must be some classical mechanical way to describe the atom. It's not some really crazy esoteric object that you can't visualize and like in quantum theory. Although it's treated classically, you're dealing with a mini black hole. which has infinite potential. You're dealing with a very, very amazing esoteric object that has infinite connection to all the things in the universe. So it's not boring. Mechanical and classical is not boring. Mechanical is actually completely non-linear. It's just that we've confused our little mechanics of our cars and our devices with the mechanics of the universe, which is quite different. Mechanics in the universe is quite different. Let me give you an example. Something that seems to be obvious, right? You're going to say, the mechanical function of my hand moving from here to there. Sounds pretty simple, right? Should be easy to measure, should be easy to calculate. My hand goes from A to B. I can calculate how fast it did that. Can you? Let's see. Okay. Well, if I close the system, which many of our laws of physics all start with this statement, within a closed system, right? And the laws of entropy, the laws of mechanics commonly start with this. Within a closed system. Then you look in a physics book, closed system. What's the definition? No such thing has ever been found. Oh, okay. So now, in a closed system, I can calculate my hand when at like 0.1% of a mile per hour moving across from A to B. But if there's no such thing, if everything is embedded into larger and into larger and into larger and into larger and into smaller and into smaller and into smaller and into smaller, then it's different. If I try to calculate my hand going from A to B now, I have to say, well, while it was going from A to B, the Earth spinned a little bit. So I have to add that, because my hand is not isolated from the spin of the Earth. It's not in a closed system. So I have to add that. Now my hand is already moving very fast. And then I got to say, oh, well, the Earth is spinning around the sun. So I have to add that. And then I have to add the sun is spinning around the galaxy. Oh, my hand is going thousands of miles per second already. Right? And then the galaxy is turning in a cluster, in a cluster, in a supercluster, in a supercluster, in the universe. And the universe most likely is spinning a larger one, and a larger one, and a larger one. Multiple. Oh, my hand is going at the speed of light. You see, mechanical functions are not so boring. They're a little nonlinear. So how do I solve that? Does anything move? What is this? The only solution is to realize my hand is appearing and disappearing, appearing and disappearing, appearing and disappearing in sequence that are occurring so fast at the speed of light that it appears continuous. It's actually my hand is the vacuum, the whole universe, and then back to my hand, and then the vacuum, the whole universe, and back to my hand. And that's how the universe actually knows where my hand is. So that it can coordinate everything else. You guys are following this? So, my hand is actually it's just like a movie, right? You have a frame and then you have a space, and you have a frame and you have a space. But when you run the movie fast enough, you don't see the spaces, you just see the movement continuous. Well, this is happening at the speed of light, so there's no way you're going to see the spaces. You might feel the spaces if you're really, really, really good at experiencing your vacuum self. And if you're really good at experiencing your vacuum self, that's because you spent a lot of time going towards that vacuum, like some masters might have been able to do. And all of a sudden you get these masters that can appear here and disappear over there. You know, you could say, hey, when my hand disappeared here, I want it to reappear over there without going in between. Now, if you succeed at doing that, don't forget to take your body with your hand. Because it could be very uncomfortable to have your hand over there and your body over there. But you know, telekinesis, moving object at a distance, all these things start to make sense. And that's why I was saying mechanical functions are very amazing, very esoteric, very remarkable. They imply infinities, nonlinear function, relationship between all things connected. So, I got sidetracked again. Now, there's another calculation we could do with this model. And that is to calculate the anomalous magnetic moment. The anomalous magnetic moment is called that way because in quantum theory, it's called anomalous because they don't know where the magnetic moment of the atom came from. It's remarkable. You would think we know that. You know, ultimately that means, if you push it a little bit, ultimately that means that if you ask a physicist, where does electricity comes from? He can't really tell you. Because he will say it's a charged particle moving through a field, right? Producing an electric field. But if you say, where did the charge come from? The charge of the electron or the charge of the proton? Don't know. Don't know where it came from. So it's called anomalous. Well, what we did is we took a little proton and we did a really, really rough calculation. Okay, we're going to improve on that calculation. I was presenting this to a physicist the other day in Basque Country, and she was saying, why did you do that calculation yet? I'm like, you know, I'm busy. I need help. Please help us. We took a little Schwarzschild proton and we said we put a little charge on it. And then we calculated how much magnetic field that would create. We took the measured charge, right? And we just stuck it on top of our proton. And so charge is going to equal, the magnetic moment is going to equal the charge multiplied by the radius multiplied by the velocity over 2. We plug all the numbers in, and the result is 3.17 multiplied by 10 to the minus 26 joule Tesla. The measured value in laboratory is 1.4 multiplied by 10 to minus 26 joule Tesla. Very close, considering this charge here should be around the whole proton, not just on the point. So we get the right answer for the charge of the atom. Now we can explain that charge comes from the vacuum interacting, producing boundary condition of the black hole atom. And that charge is coming from this interaction. So this is very significant because all of a sudden we can extrapolate charge directly out of the vacuum. It's the vacuum that produces charge. Well, charge and spin, right? The two combine, producing the magnetic moment. Does anybody see a possibility here? All of a sudden, we have found the source of charge. And the source seems to be an energy density of 10 to the 93 grams per centimeter cube. Meanwhile, on little planet Earth over here, people are walking around going, dude, there's not enough energy for everybody. We gotta fight for it. We got a war. I need that energy. Meanwhile, every single atom in the universe is extracting it directly from the vacuum using spin. This is a possibility for humanity right here, to start to understand how to extract energy directly out of the source of energy that produces all of the universe. Thank you. Thank you. And remember the numbers? 10 to the minus 39% of the energy in a centimeter cube in a proton volume is the only thing that's needed to produce all the proton. So imagine if we extract a little teeny weeny beady little teeny thing of the amount of energy that's there in technological ways, we can power the whole planet for thousands and thousands of years. Right? And we could extract that energy, and we can extract that energy anywhere in space. Anywhere in the universe, we will have access to infinite amount of energy. Can you imagine a society that reached that level? What it looks like? Do you think they are going to war with each other to get some oil? Most likely not. Do you think they go to war with each other to try to get more land? Most likely not. Why? Because if you have this level of energy, you can curve space-time. You can produce wormholes. You can make black holes in laboratory. You have space drives instantaneously. We are very, very close to this moment. You would be surprised what goes on in laboratories around the world. There is a possibility there that will change our world. We have reached that level in which a society must come off the surface of their planet. Why? Planets are not a good place to hang around for too long. They're not stable. Cosmologically speaking, you got a pretty short amount of time to get your you-know-what together and get off. Right? I'm not the only one saying that anymore, you know. Now, this is the second time it's mentioned. It makes the news every time. Stephen Hawking has been saying we have to get off the surface. The first time he mentioned this a few years ago in Japan, he got in a lot of trouble for saying that. And then he did it again a few months ago. It's crucial. Any society that reaches higher levels of consciousness must as well reach higher level of technology that matches that consciousness. Any society that reaches higher levels of evolution must learn to live free, unattached to a surface in the universe. Because planet change and very little change makes big difference for little humans on it. You know, it's remarkable that we're still here. People don't realize, again, it's a thing of scale. The earth is like a little grain of sand beside the sun, a little teeny weeny thing. And the sun has sun flares. It blows sun flares all the time. And it goes through periods of time where it blows really big sun flares. And the Earth atmosphere is like if you took a billiard ball and you painted a little shellac on it. You know, you just paint it like you paint on your deck, right? That's actually the thickness of our atmosphere. Okay? One sun flare, that's a good one, in the right direction, and the Earth atmosphere just goes, sit. In the solar system, the rest of the planets probably wouldn't even notice. They go, sit, and they go, oh, what was that? Oh, that was the Earth atmosphere just went. Oh, okay. Humans down here, though, run out of air instantaneously, right? Done. All of a sudden, this planet looks like Mars. It's actually remarkable that that hasn't happened yet. The probabilities are very high. Never mind all the meteorites and the comets and all the stuff that's being thrown at the Earth that we keep missing. There's a program that was done by an astronomer where the Earth is turning around the sun in the wrong model, you know, because it should be a spiral. But there's a little line, a white line that appears for every meteorite that missed the Earth, right? That's big enough to create large cataclysm. And after a few years of the Earth going around the sun, the screen is full of white line, full. It's constantly missing us. We live in grace. We do. But I don't think we should push it. I think we're close to this moment where our society has reached levels where we have exhausted a lot of our resources and we have to come to the next level. And in order to come to that next level, the only thing we must actually understand and apply is how gravitational field and the structure of the vacuum, the energy at the source of creation works. As soon as we understand that, we're done. No more struggle. No more lack. You know, the only reason we war is because we have a lack mentality. That means we think there's limited amount of resources and we got to war for them. So this is on its way. The only problem, the only hic is, will we, as a morphogenic field, be able to actually make that transition? It's a very, very difficult transition. Now, what I'm talking about might sound to you like completely outrageous. You know, it sounds like, is he talking about the Jetsons? Do you guys have the Jetsons? No, okay. You know, it's hard to visualize flying saucers and things, right? But imagine that you were a person that lived on that lake near where the Wright brothers flew the first plane. And you went to that person, like a person came to you, 2 weeks before the Wright brothers flew the first plane and told you, in 2 weeks, these people are going to come here and they're going to take an object that weighs thousands of pounds and they're going to fly it through the air just by pushing the air around it. You would have said, no way. No way. And in fact, all of the physics community of the time all said, no way. There's all sorts of articles you can get from that time of very prominent physicists all around the world saying, there's no way you can do that. And for almost 5 years, the physics community around the world said that the Wright brothers flying plane was a hoax. Because all calculations show that you could not do that. It sounded like exactly what I'm talking to you about at the time. It sounded like free energy. The idea that a system can produce enough power in the wind around it to lift its own weight sounded completely outside of the physics possible. They didn't notice that birds were flying over their head. Many physicists don't come out of their little room, in the university. So, this is where we're at. We're very, very close. And this starts to give us the understanding on how the universe produced charge, how the universe produced electricity, and it produced a lot of it. A lot. So, it's very important. If we wanted to understand what are the structures that produce such an effect, if we wanted to actually start engineering a device that made that power, that could tap into that vacuum, we would have to understand exactly how the vacuum structure produces that charge. Now we know that most likely from these equations, the vacuum structure does produce it. So how does it though? Well, early on, you see, most people don't know, but I did most of this research, some 25 years of research, because there is important technological discoveries to be made. Most people don't know. I'm very interested in hardware, in technology. Because I do a lot of philosophy and a lot of theoretical physics, they think I don't do that part. But now I'm starting to be more vocal about it. I've done some 11 years of work in laboratory. I do a lot of engineering. And in order to understand how to build such a device, I had to understand what are the fundamental mechanics that allows the structure of the vacuum to produce a singularity, to produce a point of infinite density. Because if I understood these dynamics, then I could reproduce it in a laboratory. So I realized that when we look at black holes, which is with Einstein field equation, there was something strange. That is, the way we were treating spin, rotation, was not quite right. I realized that what we had done is we had attached the frame of reference to the rotation of the black hole, the rotating metric. What does that mean? The reason why we did this is because when they tried to calculate the dynamics of a spinning black hole with Einstein's equation, they realized that mechanical spin is extremely complicated. It has Coriolis effect, and it has, there is gyroscopic effect and all this, and they wanted to eliminate the complexity. When we do that, typically we miss something very important. So how did they do that? They said, hey, we're going to eliminate gyroscopic effects by attaching the frame of reference to the rotating metric. So what does that mean? Imagine you have a V8 motor here, okay, a large engine. And there's a shaft coming out of the engine. And the shaft is spinning at 5,000 RPM. And you're standing in front of that shaft, and in a great moment of stupidity, you decide to grab onto it. Too much testosterone or something. You will experience gyroscopic effects. You will experience the effects of spin. One of them is going to be your shearing. Shearing will be your skin flying away from you at high velocity. You will experience thermodynamic effect. That would be the smoke coming off your hands. You will experience those things. However, if I grabbed your frame of reference, if I grabbed you at the exact same time as you grabbed onto the shaft and spun you at the same rate, you wouldn't experience any of that. Right? But I could still say I'm accounting for spin because I can count how many times you went around. This is what they did. So what I said is that's not appropriate. We have to stabilize the frame of reference in the structure of the vacuum, meaning the vacuum is the frame of reference. And then the solution to Einstein field equation is different. So this is another paper I published with Dr. Rauscher. She helped me a lot with the math in there because those are much more complicated math, which I'm not going to go through with you today. So don't panic. But Dr. Rauscher and I wrote the math for this. It's the first paper I published. It's called The Origin of Spin. And it adds torque and Coriolis effect to space-time. It says, Einstein said that space-time curves to produce gravity. This new equation says when it curves, it curls. Like water going down the drain, and it produces spin. And so when we did that, then the solution, instead of a black hole looking like a sphere, it looks like a double torus. A torus is like a donut. You guys have donuts? Yeah, good. Whew. If you have two donuts spinning in opposite direction, now you have a double torus. And why is there two spinning in opposite direction? Because this Coriolis effect. One in one direction, the other one in the other. Like there's hurricane and typhoons, right? In the northern hemisphere, they're spinning in one direction, typhoons are spinning in the other. And so now you have this toroidal field instead of this idea that the surface of systems are spherical, they're actually toroidal. And because they're toroidal, now you have a function, now you have the mechanics of feedback. It's expanding and contracting at the same time. Right? For every action, there's an equal and opposite reaction. The universe is expanding and contracting at the same time. Actually, last month was very exciting for me because they found that when they look in one direction, it seems to be contracting, and when they look in the other direction, it seems to be expanding. New data came out. So now they're starting to realize, wait, it's happening at the same time. It's not like the universe expands and then contracts. It's happening at the same time. And this is why you have feedback of information. You can think of this as your light body. You know, with this point in the middle being your heart chakra. And actually, I teach a meditation based on that. And maybe the next time I come to Spain, I can do a weekend workshop, which I call the delegate program, where I can teach this meditation. And that, then you can see that like it comes out of the equator, comes back up to the poles, come out, and every time it comes around, you see what's in the middle of the donut. Space, right? The vacuum. So, where you see, if this is the new solution to black holes, where the point of infinite density is space, is the vacuum. The vacuum is the infinite density. You all follow this? This is why the vacuum is connecting all the points, is because it can go to the middle. So it's always connected, it's never separated. You are the center of one of those double torus. You can even think of it with like a hole here and a hole here, you know. You get the idea. You can look at it as like the two hemispheres of your brain, you know, with your ears. You put that on the side, right? So, we are at that point where we find that this interaction here, you see, in order it comes out, the information goes back in, it informs the vacuum in the center, comes back out, goes back in, informs the vacuum in the center. You can think of these as the electron and the positron. It's like every little teeny atoms you're made of is like this. And interestingly, when you look at it from the top, it looks like the I Ching. ancient symbol. And actually, I have a brand new animation. I did an animation of the I Ching. Actually, not the I Ching, I'm sorry. The Yin Yang. Sorry. I got a little lost. And let me just pull that out real quick. You guys don't mind? Okay, I just want to show you quickly. Let's see. So, let me bring it out. Can you all see that? This has been done just recently. Some of the first times I show it in public. It was in my brain for almost 25 years. I finally got it done. I was trying to solve at the time, how does the black dot end up in the middle of the white? And how does the white dot end up in the middle of the black? And I realized thank you. I finally got it out of my brain. And, I thought it worked when I was working it out in my brain, but it was good to see it actually done. And you can see that this is the only way you can solve for no discontinuity, because the philosophy of the I Ching and the Yin Yang is that they cannot be discontinuity. So, this is the only way to solve it. I'm glad to be able to show it. So we have to go for lunch. So, thank you so much. After lunch, thank you. Thank you. Thank you. And after lunch, we're going to talk a little bit about ancient civilization. So have a wonderful vacuum lunch.